So I'm going to make your lives a little bit easier, okay? So I'm not teaching you anything brand new in terms of the way we calculate things. It's going to make it a little bit easier. So I will talk about factorial first. So when you see a number with an exclamation mark, right? 6 with an exclamation mark, we call it 6 factorial. And what that means is you take the number and you multiply it by one less than the one before until you get to 1. You see that? Can you see the implications of this? We've done this quite often, right? When we have 6 people line up for a picture or 6 letters in a word, we would do this, right? 6, 5, 4, 3. So this is our shortcut. And so to access the exclamation mark, we use alpha window 9. Let's do that right away so we know how to actually find it. So let's press 6, and then we're going to go alpha window. The alpha button followed by window. And there's lots of options, right? But 7, 8, and 9 are the ones we're going to use in this unit moving forward. You want to select the last one. So I just press 9, to be honest. It saves you so much time. If you just press number 9, it will bring the factorial with you. So I'll do it one more time. I'll clear my screen. 6, alpha, window, and select the 9th option, or just press 9. If you hit enter, it tells you what it is. It's 720. So we'll calculate the following. By the way, I need you to know how to expand. So if it's 6 factorial, you should know that this is 6 times 5 times 4. So that's 720. What about negative 5 factorial? Remember, please look up if you're new to this calculator. Negative, we got to use the negative button down here. Don't use minus. So negative 5, that's called a factorial. So alpha window 9. You should get a math error, okay? Math error, why is that? What happens to a negative 5 if you keep subtracting 1 from it? What will happen? This will be negative 5 times, what's 1 less than negative 5? Negative 6. What's 1 less than negative 6? Negative 8. Is this ever going to end? It's infinite. It never stops. So we go dot, dot, dot. So we just say undefined. I've never seen this come up, but I need you to be prepared for it just in case the province decides this year is the year, right? But it's undefined. You can't take the factorial of it because you'll never end up with just 1, right? At the end, it'll just keep going negative infinity, and so it never stops. So it's undefined, but you can take negative 8 factorial. That is possible because this is saying negative 8 factorial like this. That's what that is really saying. So you'll go negative, try 8 factorial, type that in. You should get 40,320. So this is simply negative 40,320. 0 factorial. Try 0 factorial. What is 0 factorial? It's just 1. Just remember, I don't even know if you need to remember that. You just use your calculator if you, yeah. I'm not going to really spend too much time. Okay, so 0 factorial is 1, just a fact. And here you have some examples. I need you to be able to do these not just by typing them in, but actually you got to know what factorials do. Like, what is a factorial next to a number? What is a factorial next to a variable? What is that? Okay, so I'm going to ask you to evaluate. What does evaluate mean? It means to expand and try to cancel values out. Okay, so watch what I'm going to do here. Listen carefully here. If you've got factorial in the numerator, factorial in the denominator, what I want to do is I want to try to get rid of factorials. So which one is the bigger number out of these two? 8 is, right? 8 factorial. So watch what I'm going to do. I'm going to go 8 times 7 times 6. And I'm going to say I'll stop there. We know this keeps going, right? 6, 5, 4, 3, 2, 1, correct? Why am I stopping there? Because there's a 6 factorial in the denominator. And so I'm going to use my red pen for this. I can cancel them out. And so really, what is this? It's just 8 times 7, right? Which is 56. I will argue that this you could have probably figured out using your calculator. If you had gone 8 factorial divided by 6 factorial, no problem. Try it, actually. Try it real quick. By the way, if it says go to ever, if it gives you the option between quitting and go to the problem, select go to, and it's going to say, I don't like that factorial there. I can't do this, right? Anyways, clear? I'll go 7 alpha window 9 divided by 6 alpha window 9. So many buttons for just a simple, sorry, what did I do? I can't talk and, there, 56, okay? 8 factorial divided by 6 factorial is 56. No problem. Let's do this one. Which one is greater? 7 factorial? 7, 6, 5, 4, 3. I'm going to keep going till I'm done. 7, 6, 5, 4, 3, 2, 1. What about the bottom? 3 factorial is what? 3, 2, 1, correct? Is this okay, Mr. Dirksen? Because I got rid of the factorials. This is also okay. Cancel the 1s, cancel the 2s, cancel the 3s, and now you're left with that. That gives you 840. One more. 6 factorial. 6, 5. I'll stop at 4. One more time, because you might fall asleep on me here. What does 4 factorial mean? 4, 3, 2, 1. Okay, guys? It's just a lazy way to write less in math. Okay, that's just basically what it is. And 4 factorial is at the bottom. And I stopped there because they're the same. Because all the 4s would cancel out, all the 3s would cancel out, all the 2s and the 1s. So why do that? Why bother? So this is just 30. Okay? Try this one on your calculator right here, this one. Because you could get this on an exam and they're like, evaluate this. And some students are tempted to just type this into their calculator. What do you get? Divided by 97 factorial. Window error overflow. It's too much, can't handle it. 100 factorial is a really, really big number. So a calculator can't do it. So you got to go 100. What's one less than 100? 99, 98, 97. Factorial, I stop because I know that I have a 97 factorial at the bottom. So the 97s would cancel out, the 96s, the 95s, the 94s, all of them would cancel out. So I just do that. And so we are smarter than the calculator, right? Doesn't happen very often, right? 970, 200.
Excuse the interruption, Judge G. Burr to the office, please. Judge G. Burr to the office.
Okay. I'm gonna skip this one for now because it's just 4 times 3 factorial. What I would like you to have on your study sheet to speed things up, I'm gonna ask you to do this. Study sheet for this unit. We're gonna have 2 factorial is 4, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120, 6 factorial is 720, 7 factorial is 5,040, 8 factorial is 40,320. Oh yeah, sorry. 2 factorial is 2. Thank you. I'm just gotta make sure you don't fall asleep on me. I should put that on my course outline. Disclaimer, you will be tricked on a regular basis to check for whether or not you're awake. Why am I doing this? Because it saves you from having to go, what is 6 factorial? 6 alpha window 9, like it's so tedious. These are gonna be so popular, very, very popular. It's just easier to just have it on your study sheet and just go use them, okay? All right, keep going. Let's go to 14. This is the one I would like you to be prepared for. It will show up. It'll be worth a mark most likely. Go to 14. And let's say this reads evaluate. Evaluate this expression. I'll tell you this. Evaluate means no factorials, okay? Oh, I get it, Mr. Erickson. Evaluate means no. So if somebody's like, hey, you want to go out? You're like, evaluate. No? Anyways, 7. So here you've got multiple factorials. 17, 16, 15, 14. I'll stop at 14 factorial because I see a 14 down here. What about the 3, you may ask? Just expand it. Everything is multiplying. You cancel out the 14s. And at this point, you just plug that into your calculator if you want. If you like mental math, you can simplify all these numbers. Okay? Should I do that? No. I think I'm just going to ask you to figure out the top. I don't have that in my key here. That's 4,080, and the bottom is 6. That's 680. That's good enough. But I need you to at least show me one step where you cancel out the factorials, right? Don't just go from here to the final answer. Just give me a little bit of a trail, and that's good enough, okay? I'll leave this one up to you. I'll tell you that that is 220. That's the answer to this one if you want to try that yourself. Okay, so here, this next part right here is, I'm going to tell you, you've already done this. You've used this, but you didn't see it. Right now, I'm going to bring it to light. So just so you know, for this part, for permutations, highlight that all objects are distinguishable / unique. The NPR notation is used to represent the number of permutations, combinations that can be made from a set of n different objects, where only R objects, number of objects are used in an arrangement. When we use when we use NPR, we're going to imply that there's no repetition allowed. Okay? And so here's your formula. You don't have to have the word formula in there, right? You just go NPR. And I will say this. This is the short and sweet version of NPR. Okay? From n number of objects, pick R at a time. I would have this next to it, okay? So NPR, if we use this, it's like, given that we have, let's say, 10 objects, we want to pick R at a time. So this could be 5 at a time, or 7 at a time, or whatever the case may be. It may make more sense to you later, okay? So let's look at these examples here. 5P2, 5 pick 2. Using this formula right here, remember, n is the first number. So we're going to go 5 factorial over n minus r. Like we go n minus r. 5 minus 2 factorial. That ends up being 5 factorial over 3 factorial. Can we break this down? Please do that with me. Sorry, I'm going to do it right next to you. 5, 4, 3 factorial. I'm going to stop there. You don't have to do this down the road. Okay, I'm just going to show you. Cancel out the 3 factorials. What are you left with at the top? 5 times 4, which is 20. I want you to grab your calculators now and use this and use one of the functions we have. We're good? Alpha window. Where's NPR there? You see it? Option 7. Select it, and then just plug in 5 for the first box, that's your N, and 2 for your second box, which is your R. You should get 20. Alpha window 7. Here you go, alpha window 7. 5, you got to go arrow, you got to use side arrow to fill in the rest, that's 20. Okay? Yeah.
So for these extra questions, do you even have to show the work for the R?
No. No. The beauty will be that unless I tell you to evaluate or to actually use the formula, this will just be something we use on a regular basis to speed up the process. Okay? So can I give you a scenario here? Just try to follow my train of thought here. I've got 5 students, okay, volunteering to line up on a picture of 2 students at a time. So from the 5, I have to figure out how many arrangements can I make with those 5. Yeah. So this would be 5 for the first slot, 4 for the second slot, right? Which is 20 arrangements. So earlier with the fundamental counting principle, we would have gone 5 and 4 get 20. But you can also say 5 pick 2 is 20. Okay, let's do another one. Let's do this one here. 100 pick 2. From 100 students, we'll pick 2 at a time. Let's do the actual formula. I know it's a little tedious, but I need you to know how to do it, just in case. This would be 100 factorial over 98 factorial. Okay? That is what? 100 times 99 times 98 factorial over 98 factorial. Cancel out. What are you left with? 100 times 99, which is 9,900 options, right? How many slots did we fill? You see this, what I'm doing here? I'm turning this permutation into a fundamental counting principle. Guys, from 100, how many did we pick? From 100, we picked 2, right? So it's 100 times 99. Earlier, from 5, we picked 2. So what did we start with? 5, 4. Okay. Yeah. Can you say that one more time? Right. How many times? Yes. How many times could you take those 5 objects and form it into 2? Yes. Yeah. Okay. Another one here. 5 pick 5. Can you just tell me how many are we picking? So we'll have 5 slots to fill, correct? What are we going to start with? 5 and then 4 and then 3, 2, 1. This would be a scenario where you have a word with 5 letters. How many words can you create with those 5? You're using all slots. Let's do the formula though. 5 factorial over 5 minus 5 factorial. That is 5 factorial over, what is 5 minus 5? 0. Is there such a thing as 0 factorial? It's 1. So this is 1, right? We can just do this. 5, 4, 3, 2, 1. Yes. It's just 5 factorial. So a note here. 6 pick 6 is the same thing as 6 factorial. 5 pick 5 is the same thing as 5 factorial. Like you're using all of them. Okay? And that's just a note. We're using all of them. We're not just picking 2 at a time or 3 at a time. We're using all of them. We're filling up every single slot. Okay? So if you have 6 students and you want all 6 students to line up for this picture, you're trying to see how many ways can you arrange those 6 students. Okay? Okay, I'm going to move on. I think at this point, you're ready for applying this to a word problem. Okay? Mr. Erickson, should I have the formula for NPR on my study sheet? What do you think? No, not maybe. Definitely. Okay. Billiard balls or pool balls, same thing, pool. We have 16 billiard balls. What is the number of possible ways to pick 3 balls without replacing the balls? Okay. We want to use the fundamental counting principle first, so let's do that. How many are we picking? 3. Hold on, I need you to make sure you understand this. We've got 16, right? And we're picking from the 16 to figure out 3, right? 3 arranged. Is repetition allowed here? No, right? Because you have 16, you're grabbing from them. Every time you grab one, it's going to be fewer left, right? So we can't just go 16, 16, 16. You can't in this case. Unless they explicitly told you to do that, we're assuming not, okay? This is basically another way of saying no repetition allowed. Okay? This is saying no repetition allowed. That means we're going to go 16, 15, 14. Okay? So we're going to come up with that. And that is what? My answer key is a little off because I changed the booklet for you guys a little bit. I get 3,360. That's how many different ways you can arrange those 16. Okay? They're all unique. They all have a different number. Okay? So we consider every single one of them different. Okay? What about factorial notation? What does that even mean? I want you to use NPR. Okay? Should be lowercase, but that's okay. How could we write this using our permutation concept? How many do we have? N would be what? 16 total, right? How many are we picking at a time? We only want 3 at a time, correct? So this would be 16, pick 3. Do you think the answer will be different than what we had earlier? No, right? It's going to be the same answer. So we're going to go 16 factorial over 16 minus 3. Don't worry, you're not going to have to use the formula. If you do my test or quiz, if this is all I ask you, how many ways can you arrange them? If you just go 16, pick 3, and you give me the answer, you're fine. Mr. Dirksen, what if I just love the fundamental counting principle? I want to stick with that. You're going to be fine. I'm just giving you tools to work with this, okay? Whatever works for you. 16 factorial over 13 factorial. Remember this? How do we break this down? 16, 15, 14, 13. I'm going to pretend to be surprised by this, okay? Oh, wow. Doesn't this look exactly the same as before? Jeez. Yeah. No, but seriously, what is the 13 factorial doing here? Like, why is it dividing? Why? We couldn't just say 16 factorial. What if we just said 16 factorial? Yes? It goes all the way down to 1, yeah. So we're assuming... Pay attention to this. If 16 factorial is all it's saying, we're assuming we're taking all 16 and lining them up, right? But we don't care about all 16 at a time. We only care about 3 at a time. So permutation is dividing out all of those arrangements that we don't care about. We only care about the arrangements where we have 3 at a time. That's why I wanted to use the formula. It really isn't necessary. You could have just, what is the answer, by the way? Let's use our calculators to do 16p3. Oh, you can use copy-paste, guys, by the way, right? I'm just going to go up. I used permutation just 2 lines ago. Let me see. Can I do 16 here? Yeah, I can. 16, pick 3, boom, 3,360. I wouldn't even hurt a fly, okay? Anyways, so what I'm going to say is I'm going to say 15 to 16. Can you do both, please? I know it's a little bit annoying right now, but I want you to use the permutation way of doing it, and I want you to use the fundamental counting principle so you see the similarities. I think it's a little bit... It's not quite enough in my opinion. So I'm going to say page 20 as well. 15 to 16 and 20. Can you see that? Page 16, sorry, 15 to 16, and page 20. I will post everything to page 23, by the way. There might be questions that you cannot do yet. Okay? We're gonna get pickier. We're gonna be like, what if two friends wanna be right beside each other? You can't separate them. They gotta stick together in your arrangement. What happens then, right? Or what happens if I have that problem where the two people that are together are always like annoying and they can't stop talking? I can't have them together. How does the arrangement change if I have to have them separated? Okay, so we're gonna do all that tomorrow. Thank you guys.